Hi guys, back again for part 2 of the lab. So here's what's left. Crazy, right? Here, let me show you a bird's eye view. What? What's that? What does that look like? That is your precipitate. That is copper on the nails. Let me pull the nails out. Put them up here so you can see it. Pull the nails out. I'm going to leave the precipitate in there. There's the nails. Actually, I'm going to rinse off any precipitate back in the, because we want just the iron nails. Okay, there's one. And there's the other one. Okay, I'll dry those and mask them. Now, what color is the solution? Now it's yellowish green. Do you remember when we were doing chemical reactions and I said if it's copper containing solution it's going to be bluish. If it's iron containing it's going to be yellowish, brownish. And that precipitate, can you see that? Does that look kind of like a penny? Once I filter it, then I think you'll be able to see it. Okay, so right now, what I'm going to do is decant the liquid. Oh, so the nails didn't get all used up, but the copper did. The copper chloride, because if it was copper chloride, it would still be a blue solution. It's not. It's a greenish, it's actually a brownish yellow solution, more yellow. Okay, I'm going to decant the liquid, which means I'm going to pour off just the liquid and save the precipitate behind. Okay, I'm going to fold my filter paper. I miss you guys asking, how do I fold my filter paper? Or seeing that you did it wrong. Fold it in half again, pull out so that it makes a cone, put it in, and then I'm going to make sure I've got all of that liquid, and I'm going to rinse off my precipitate. Actually, I'm going to pour it through there, rinse it 3 times so that I can make sure I've got all of the copper chloride solution off of it, or even, I guess now it's iron chloride solution in there. Okay, so I am going to finish up filtering it, because you guys don't want to watch me filter it. Here, I will. Mask the nails though, so we can see how much they lost. So what I was saying is I'm going to finish filtering the precipitate, rinsing it and filtering it, and then I'm going to dry it in the drying oven, and so I will have a final mass of the precipitate on the PDF file that I give you of the data. Okay, so the nails after, wow, 4.00 exactly. That's weird. They only lost 0.61 grams. 4.00 grams. Okay, so I wrote that down. All right, and now I will finish rinsing the precipitate, get it filtered, and I will dry it, and then I will post the final mass of the product on the PDF that I'll put out for class tomorrow. So then, you guys, this will be your lab that you'll look at. I already made a data table for you. You're going to write the balanced equation, and it's an iron 2 compound that is formed. That's this liquid right here. It's iron 2 chloride that's in that beaker, dissolved in that beaker. So it's a single displacement reaction. Iron plus copper chloride aqueous yields iron chloride aqueous and copper solid. Okay, so then you have to calculate the mass of the iron used in the reaction. I already told you that. That was 0.61 grams. 4, which was the iron, the nails before, minus 4.61 minus 4, so it's 0.61. And then mass of copper precipitated, that will be on your data table. Then you're going to convert the mass of copper precipitated to moles and the mass of iron used to moles, and then make a mole ratio. So you're going to take those 2 moles and put them over one another, and it should be the same as it is in the balanced equation. And in the balanced equation, it should be 1 to 1. 1 iron to 1 copper. So once we figure out these moles, it should be pretty close to 1 to 1. You don't have to do number 8 where it says calculate your percent error, but you are going to write a conclusion. Okay? All right. So that's it. It's our last lab. Bye, guys. Miss you.